The free radical substitution reaction is a reaction that alkanes can undergo with halogens, chlorine or bromine in the presence of UV light. UV light is essential. This reaction doesn't happen in the dark. This is a short video, so I'm not going to talk about what we mean by homolytic cleavage. You need to know that definition and how that compares and differs with heterolytic cleavage. You also need to know a definition for the word free radical, or sometimes shortened just a radical. But the mechanism to practice, the things to include, I'll show the bromine-bromine or chlorine-bromine or chlorine-chlorine bond. The reaction is initiated by ultraviolet light, causing homolytic cleavage of that bond. You do need to have the UV over there. You do need to be able to show those half-headed arrows forming two bromine atoms, bromine radicals that have unpaired electrons. Propagation is in two stages, which repeat again and again and again. A little bit of the bromine is formed, and one of those bromine atoms starts on a path of propagation. It gets used again and again, and recycled and used again and again. And it will react with an alkane, or a molecule that's got an alkyl group hanging from it, and react with it. This bromine will rip a hydrogen from the methane. Look at the reactants here. There's either CH4 or Br2 to react with. A little bit of the Br2 has been turned into bromine atoms, but most of the Br2 is present. So the Br dot formed either had to react with bromine or CH4. Reacting with Br2 is non-productive. Reaction with methane causes step propagation 1, where the bromine radical rips a hydrogen atom off the methane to produce a methyl radical, or an alkyl radical. In other words, that carbon now has an unpaired electron. There's 7 electrons in the outside of that carbon atom, 2 between each of the covalent bonds with hydrogen, so it looks something like this, and then 1 electron there. The byproduct of that must, of course, be the product of that hydrogen combining with the bromine. That thing is extremely reactive and reacts in propagation 2, which is again the step which repeats again and again and again, 1, 2, 1, 2, 1, 2, over and over. This methyl radical has got a choice of reacting with either the methane, which is non-productive, doesn't change in any way. We already know the methane reacts with the Br dot, so it has to be that the methyl reacts with the Br2. So that thing that forms reacts with the Br2, lots of which is still in the reaction mixture. Br2 reacts with CH3 dot that's just formed, forming the product that we know forms CH3Br, and the other bromine that was here forms Br dot, which gets involved in doing propagation 1 again, which produces this, and it goes back and forth and back and forth. Then the 3 termination step, or possible termination steps, are a combination of any 2 of those radical species formed, resulting in stopping of the reaction. So the 2, you can either have the 2 Br dots reforming, covalent bond to make Br2, the 2 CH3s combining to give methane, to give ethane, forming that covalent bond, or CH3 combining with a Br dot. Those reactions happen when we start to run out of the reactants, and these reactions start to slow down and eventually stop. So that's free radical substitution short. Hopefully that's helpful.